Hello, everyone. This is Mr. Younger. Thought I'd go over some of the things that I did in the actual the PowerPoint on self-addressed envelope. So I wanted to go over some of the claims I made in there and also show you some of the things that would often be used in a typical science class. A lot of these I'm not necessarily requiring you guys to use, but I found them extremely helpful in other science classes as well as in everyday life, even to the point of actually earning jobs and getting promotions and stuff based on just this basic knowledge of unit conversion. So I thought I'd go over that a little bit. We're going to start off looking at the actual PowerPoint from self-addressed envelope, and then I'm going to sort of talk about each slide photograph and tell you, how I made the claim that I made. So let me start off by sharing my screen so you can see what slide I'm talking about right now. So this slide right here, remember, was 52.8 feet by 52.8 feet. So that's a very typical thing that someone might show you is they'll give you some units and some numbers. So 52.8 feet for starters is a number with a unit. And when we actually use that, I might be able to express it in a different set of units. For instance, if someone took this picture and they happen to be from somewhere in Europe, they probably would not be using 52.8 feet. They'd probably be using the 16 meters that you see there. So I'm going to show you basically how you'd flip back and forth between units and between systems of units and stuff of that sort. So I just thought I'd start off with this. So we're going to take off this 52.8 feet, and then I'm going to go ahead and show you an intro to basically dealing with the system international. So this unit conversion thing that I'm doing, this converting from 52.8 feet to roughly 16 meters, that is not something that's required of this class. However, you'll see many problems and many statements in the book expecting you to try to do that, but I just don't require it in my test. But if you're interested, it's kind of neat to do. And like I said, this is something that I literally got a job and a promotion from. So maybe it'll help you, maybe it won't. It's all good. So right now I'm going to stop sharing and I'm going to go to my document camera. And on the document camera, I'll express what I'm doing. So as soon as this document cam comes up, taking a long time. There it is, finally. Okay. So make sure this is in focus. Make sure I write big enough for everybody to see. Ah, crap. Sorry about that. I hit the stop button instead of the down arrow. So I think everybody can see this pretty well. So what we have is 52.8 feet. And what we're wanting to do to that is I'm wanting to convince you that that is in fact roughly 16 meters. And there's easy ways you can actually go on the internet and there's actually have things that will automatically calculate it for you. So you can say convert 52.8 feet to meters, and you literally type that in the Google search box, and it'll actually find you a calculator that'll spit out the right answer for you. That's all well and good, but if you ever have to say mixturing oil with gas, say to run a lawnmower, or excuse me, run a weed eater or a leaf blower or a chainsaw or something like that, you're going to be sort of up Poop Creek without a paddle. So knowing this kind of stuff can actually help you. So here it is, 52.8 feet. What I know is there's 5,280 feet in a mile. I know that there is exactly 2.54 inches in, or 2.54 centimeters in an inch. I know there's exactly 12 inches in a foot. And I know there's exactly 100 centimeters in a centimeter. So these are all facts that I happen to know. You've probably heard them from somewhere in the past, but the 2.54 centimeters is exactly correct. They actually define the centimeter in terms of that. So you're not making an approximation at all. So if I want to convert this to meters, what I'm going to do is I'm going to use a principle that you know of from math. And that principle is that if you multiply a number by any number other than 1, you're going to get a different number. I don't want a different number than 52.8 feet. Okay, I want it to be exactly the same, or else I'm not making something equivalent. So the trick is with unit conversions is how do you write 1 so that it's helpful? Obviously, this is a case of 1, but if I just multiply that by 52.8, that's not going to give me anything helpful. But I might also remember that 1 could be, for instance, 2/2. Okay, so that's a neat new way. It could also be 3.14/3.14. Or I could go even further and say it's pi/pi. So with that, I think you start to see, oh, as long as the top thing is equal to the bottom thing and it's a fraction, then that is a value of 1. So if I make sense of that, or make use of that, and then recall that 5,280 feet is equal to 1 mile, I could actually convert this number of feet to miles. I don't have to do that here because I'm actually not dealing with feet yet. I mean, with miles yet, but that fact would come in handy. But what I do want to do is I want to get to meters. So I happen to know that 1 foot is 12 inches. So one way I could write 1 is I could put 1 foot down here and I could put 12 inches up here. Or I could write 1 foot up here and 12 inches down here. Now, if I put this next to here, what I see is I would get feet times feet, because what you got to remember is when you have a number that actually has a unit, then that unit is being multiplied times that number. So if I put 52.8 feet times 1 foot over 12 inches, I'd have to make this 52.8 over 1 feet over 1, so it would be a fraction, and then I'd have 1 foot over 12 inches, and the feet would multiply by feet, so I'd get feet squared divided by inches. That doesn't help me at all. But if I actually did put this over 1, because any number you can put over top of 1 is still the same value because that's just dividing by 1. If I did put the feet down in the bottom like this, just like when you reduce fractions, say from 3/7 times 4/3, that 3 cancels out with that 3 there. The same thing happens with this feet. That feet will cancel out with that one. So then I just got to make sure inches is up here, and that'll get me a conversion to inches. So when I look over here, the only fraction that is equal to 1 that has the feet in the bottom is 1 foot in the bottom and 12 inches in the top. So I could actually compute it at this point and just say, okay, 52.8 feet times 12 inches per foot cancels out the feet and gives me the number of inches. So I'm going to do that. But you could actually do all these steps in one big calculation, but I'm just going to do it right now. 52.8. All I have to do is really multiply 52.8 times 12. And technically, I'm really multiplying 1 by 1 as well. But 1 by 1 just makes 1. And then you're going to divide that 1 into the new numerator, which is 52.8 times 12. So that's the way that's the way multiplication goes with fractions. It's 52.8 times 12 times feet, which just canceled out, but I'll leave it there for right now, times inches, over 1 times 1 times feet. So again, you can see the feet cancel out. All I'm left with is inches. The 1 doesn't matter at all. So really, when you see this, you can just string all the denominators along, multiply them by each other, string all the numerators together, multiply them by each other, take the product of the numerators and divide it by the final product of the denominator, and that'll give it to you. When I did this, 52.8 times 12, I got 633.6 inches. Okay. So that's the first step. Now I've gotten 52.8 feet to inches, but I still wanted in meters. So I know another factor. I know that 1 inch is equal to 2.54 centimeters. So I could do 633.6 inches. And now I'm going to multiply it by 1 again, only this time I want to get rid of the inches. So the inches that I'm going to bring in my factor of 1 needs to be in the bottom so that they'll cancel out. And I want it to come out in centimeters, so the centimeters is what needs to be on the top. And then I just know that 2.54 centimeters is equal to 1 inch. So that gives me everything I need. Let's try to focus again on that. So 2.54 centimeters equals 1 inch. That means I need to write the 2.54 up here and the 1 inch down here. Again, what you see now is the inch cancels out with the inch, and all I'm left with is centimeters. This time, instead of doing another step, taking another calculation, getting another answer so I have to write stuff, I'm just going to keep on along the line so you can see what I'm doing. I'm going to leave it over 1. Now, I still need to get that to meters. So I also happen to know that 100 centimeters, just like there's 100 cents in a dollar, there's 100 centimeters in 1 meter. So now I want to get rid of the centimeters, which means I need to put the centimeter in the bottom. And I want to get meters in the end, so I need to put that at the top. So the 1 goes with the meter, so I'll put 1 up there. And the 100 goes with the centimeters, so I'll put 100 down here. So now all I'm going to do, this is what I was telling you before, when you have a long line of them, all you do is multiply all the numerators. So 633.6 times 2.54 times 1. And then multiply all the numerators, the denominators, 1 times 1 times 100. And then divide the final results, the final numerator by the final denominator, and you'll be done. So what I'm going to do now is say 633.6 times 2.54 times 1, which obviously I didn't have to do that, is 1609.34 over 1 times 1 times 1. Notice also, by the way, the centimeters did cancel out. So this is all 1 times 1 times 100. And of course, we never really take time to divide or use a calculator to divide by 100. 100 has 2 zeros on it, so we need to move the decimal 2 places to the left. If we were multiplying it, we'd move it 2 places to the right. So we shouldn't be using our calculator for that. So ultimately, we get that this is 16.0934 meters. Now, I only gave you 3 real digits here. I gave you the 5, the 2, and then 1 decimal place. So there's really only 3 non-placeholder digits here. So I really am being kind of careless if I carry this out more than 3 of those digits. So I really should just record this as maybe 16.0 or something like that, or 16.1 since that next digit's greater than 5. Or 5 or greater. So I'm going to just call that 16 because I roughly used 2 digits in the meter measurement. So that's how we do that. These types of units calculate or actually convert back and forth by multiplication. There's a few other ways. For instance, the decibel uses a logarithm formula. If you ever converted between Celsius and Fahrenheit, you know there's an algebraic formula for doing that one. If you ever converted between Celsius and Kelvin, you know there's just a simple additive one. For instance, if you want the Kelvin temperature, you add 273 roughly to the Celsius temperature. But a lot, and in fact most units just convert this way, just by multiplying by 1, such that the units you have disappear and the units that you want remain. So there's one such conversion we could do. Another one that I like to do is just to give you an idea of things like kilometers per hour versus miles per hour. I'll do something like this. Let's say 60 miles per hour. Now 60 miles per hour, we normally write that as mph, but I'm going to write it in the way that it's actually meant, which is miles per means divide, and hour is in the denominator. So you can say 60 miles per 1 hour if you want to go ahead and make it into a fraction. I'm going to convert this to meters per second, and I'm going to convert it to kilometers per hour. So you can check your speedometer as well. The meters per second is one that we use in physics. But it's kind of nice because I can show you a lot of neat things that comes from unit conversion. And I'm going to do it all in one step like I did here instead of step by step by step. So what I'll start off with is 60 miles over 1 hour, like that. Okay. I know that 1 mile, I'm trying to get meters up there, so I'm trying to get rid of the mile. So 1 mile is equal to 5,280 feet. So that gets me closer. And this way, by the way, I'm not making any approximations. I'm using those exact numbers again, the 2.54, the 100, and so on, 12 inches and all that good stuff. But by putting the mile down here and the foot up here, it becomes feet per hour. So if I would just want to convert miles per hour to feet per hour, I would stop there. But I don't want that. I've now gotten rid of the miles, so I'm now in feet per hour. but I want to continue going until I get to meters per second, and then later I'm going to do kilometers per hour. Okay, so next I want to get rid of the feet, so I'm going to put the feet in the bottom. But the next unit I'm going to go to is the inches, because I happen to know there's 12 inches in 1 foot. So I'll put 1 foot down here and the 12 inches up there. And I think you can see that now the feet cancel out. And I'm now getting, if I multiplied these three and divided these, or multiplied these three and multiplied, I took the top one and divided by the bottom one, I'd get basically the number of inches per hour 60 miles per hour is. Again, I don't want that, so I'm going to continue. Now I want to get from inches to centimeters so that I can get closer to the metric system, or I'll actually be in the metric system at that point. So now I'm going to get rid of the inches, so I'll put an inch down on the bottom, and I'll put a centimeter on top. I happen to know that 2.54 centimeters is equal to 1 inch. So now I can see that the inches cancel out, and I'm now doing centimeters per hour, but that's not what I want, so I'm going to continue. Next, I'm going to do meters per hour. So I happen to know that just like there's 100 cents in a dollar, there's 100 centimeters in a meter. So I'll put 100 centimeters. Notice I put the centimeters on the bottom, so it'll cancel out again, under 1 meter. Now I've exhausted all my little symbols of crossing them out, so it's kind of hard to tell what I'm doing. So now I'm going to start over with a different color. So the centimeters cancels out with centimeters. Now I'm up to meters per hour. Okay. For reasons that'll become obvious in a second, I'm going to go ahead and calculate at this point and then do the hour part, just so you can, no, I won't do that. I'll go ahead and continue like I was going. This was actually instructive anyways. So now I've got meters per hour, and I want it to meters per second. Well, I happen to know that the hour down here is in the bottom. I need to get rid of that now. So this time, to get rid of something, I need to put that unit on top, not on bottom. So that's a big learning rule. That's why I didn't stop right there where I was. I wanted to go ahead and show you this part. So that hour is now going to cancel out way over here with this hour, like that. And I'm going to get it down to, let's say, seconds, just because I know how many seconds are in an hour. There's 60 seconds in a minute, and there's 60 minutes in an hour, and 60 seconds in a minute. 60 times 60 is 3,600. So I'm going to say there's 3,600 seconds is equal to 1 hour. So I can finally go ahead and calculate that. So what I'm going to do to actually calculate it is I'm going to do 60 times 5,280 times 12 times 2.54 times 1 times 1, which obviously I'm not going to do that at all. And I'll get an answer. Then I'll do 1 times 1 times 1 times 1, which I'm not going to do at all. Then I'm going to do 100 times 3,600. And I'm going to take that first answer from multiplying the numerators and divide it by the answer I got when dividing or multiplying 100 by 3,600. So I got 60 times 5,280 times 12 times 2.54 times 1 times 1. And that gives me a pretty big number, but it's 9,656,060. And that ultimately comes out in just meters. And then 100 times 3,600 gives me, obviously we don't need to do a calculator with that at all, because it's just powers of 100 basically. So you're just going to write 36 with 4 zeros after it. And this unit turns out to be seconds. So basically I'm going to divide those two numbers. So I'll say 9,656,060 divided by 360000, and my answer will be 26.8224 meters per second. Again, that's meters per second, and I carried way more digits. Remember, this one was only 60. That could be, by rounding rules, that could be as large as 60.4 or as small as 59.5. So I really don't know even this digit specifically. It could have been 59.5, right? And that would have to, because I only wanted whole numbers, I would have to round to 60. So in fact, it's really not reasonable for me to expect these digits to be right unless this was 60.000 out to an infinite number of decimal places. So we'll say that 60 miles per hour is about equal to 26. I'll keep one extra digit, 0.8 meters per second. Remember, a meter is about a little bit more than 39 inches. It's slightly, well, it's about the height of the top of a doorknob. So that's what a meter is, and it goes 26.8 of those in a second. So that's pretty significant distance in a single second. Now, to do the kilometers per hour, I'm just going to jump from this unit right here, or this number right here, 26.8224, and I'm going to write all that just pretending like the 60 was an infinite number of decimal places, and that's meters per 1 second. So now, if I wish to convert this to kilometers per hour, I'm going to basically just convert this to kilometers and then convert this to hours. So the way I'm going to do that is I happen to know that a kilo, like a kilogram, is 1,000 grams. So a kilometer is 1,000 meters. So I want to get rid of the meter. I'm going to put it down here at the bottom. I know that 1,000 of those is equal to a kilometer. So I'll put 1 kilometer on top like that. And I also know that 3,600 seconds is equal to 1 hour. So now what I can see is my meter has canceled out with my meter, and my second has canceled out with my second, and I'm left with kilometers per hour. And that answer should be so I'm multiplying by 3,600, and then I'm going to divide by 1,000, because 1 times 1,000 times 1 is still 1,000. And I'm not even have to put the 1,000 in the calculator, because it just means move the decimal 3 places to the right. So this is going to be 96.5606 kilometers per hour. So you'll probably look on your speedometer and you'll probably see 60 miles per hour lining up with about 97 kilometers per hour. So 60 miles per hour is equal to essentially 96.6 kilometers per hour. So that's how you convert units. Like I said, it's a little different if you're converting between Fahrenheit and Celsius. It's a little different if you're converting between Celsius and Kelvin. But that's pretty much how you can do the vast majority of units. Like I said, another exception, of course, is like the decibel. That's using a logarithmic function and a multiple of 10. But the one thing I wanted to do also is just get you set up on the System International and the prefixes. So I use you can make up a little mnemonic for this, and that's pretty much the best way. But here's the prefixes. It's tera, then I put a dot dot, giga, dot dot, mega. Notice the words I'm saying. Tera, T-E-R-R-A, giga, G-I-G-A, or if you watch Back to the Future, it's giga. Mega, M-E-G-A, dot dot. Again, these dots are important, and they stop now. Kilo, that's 1,000 times. Then hecto, and then deca, which is a 2-letter prefix, believe it or not. Then the base, and in this base you put things like the meter, the gram, the lumen, or excuse me, the candela, not the lumen, so on and so forth. Then it goes deci, centi, like centimeter, milli, which is a lowercase m, and then dot dot. The next one is a Greek symbol mu for micro, and then the next one dot dot is nano, N-A-N-O, and then the next one is pico, PICO. So that's the system of units. And really all you have to do when you're using that, the simplest way to convert between one prefix and another is just imagine yourself on the prefix you are and count the number of jumps you have to take, not the number of places you are, but the number of jumps. So from tera to mega, there would be 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps. And it's to the right. So if you had a tera and you want to convert it to a mega, you're just going to move the decimal of the tera 6 places to the right. If you have a nano and you want to convert it to a milli, you're going to go 1, that's 1 jump, 2, 3, 4, 5, 6. So you're going to do 6 places to the left. So for instance, if I said, let's say 900 or 937.48, let's say picometers, and I want to convert that to micrometers. That's also called a micron or micrometer. They say it that way too when they're talking about the instrument. So I've got a picometer. That means my decimal should be right here. I need to move it to the micrometer. You can see 1, 2, 3, 4, 5, 6. So that means I'm going to move 6 places to the left. Well, that means 1, 2, 3, add a 0, 4, add a 0, 5, add a 0, 6. So that means 0 point. That's not one of the zeros I added though. So 1, 2, 3, add a 0, that's 4, add a 0, that's 5, add a 0, that's 6. So 0, 0, 0, 9, 3, 7, 4, 8 would be the number of micrometers that is. So let's double check, make sure I actually moved it the right number of places. 1, 2, 3, 4, 5, 6, that checks. By the way, this space is a spot. So for instance, if I wanted to go from, let's say 0.071 hectometers to, let's say millimeters, if I wanted to do that, I'd say, okay, I'm at the hecto. So I move once, twice, 3 times, 4 times, 5 times, 6 times. So I'm still going to move 6 times, and it's going to be to the right. So this time it's going to be 7, 1. I've moved it 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, I was supposed to move it 5, wasn't I? 1, or was it hecto? 1, 2, 3, 4, 5. Yeah, I was supposed to move it 5, so it should be that, and that would be millimeters. So that's a quick and easy way to convert back and forth within the metric system. Now, this type of unit conversion, I do expect you to be able to do, okay? You do not have to, for my courses, you don't have to actually do this type of conversion, though it is very, very powerful. Like if you want to learn how to add chlorine to a pool based on the number of parts per million, that's just a unit conversion. So that's the kind of thing that can help you out. I hope that helps you. And that's about it.